In this video, I'm going to locate and classify some more critical points of this multivariable function. So let's find the first partial derivative of f with respect to x. So that is going to be 4x cubed minus, with respect to x, it looks like minus 8y squared. The second partial derivative then with respect to x is going to be 12x squared. And the mixed partial derivative of x then with respect to y is going to be negative 16y. First partial derivative of f with respect to y will be negative 16xy plus 8y cubed. The second partial derivative with respect to y will be negative 16x plus 24y squared, and the mixed partial derivative there, so we want f of sub y with respect to x will be negative 16y. So our mixed partials, that gives me confidence that I probably found the derivatives correctly. All right, now comes the interesting part. We need to take our first order partial derivatives, set them equal to 0 to find our critical points. And over here, negative 16xy plus 8y cubed equals 0. Well, with this one, can't do much except factor out a 4, and I don't really know what that's going to do for me right now. Over here, I can factor out a variable of y. I can separate the x's and y to some degree here. I can factor out an 8y. It's going to leave me a negative 2x plus y squared. Go away. So what does that do for me? Well, what that's going to do for me is I can set both of these factors equal to 0. So I get 8y equals 0, or y equals 0. So there's something. And then I have negative 2x plus y squared equals 0. So y squared equals 2x. Now at this point in time, you might be inclined to solve this for y. You get y is equal to plus or minus the square root of 2x. But we don't really need to do that. And the reason we don't need to do that is because we can take this and substitute it in there. So I have 4x cubed minus 8 times, take out the y squared, put in 2x equals 0. 4x cubed minus 16x equals 0. We can now factor out a 4x. We'll be left with x squared minus 16 equals 0. So x equals 0. X squared equals 16. So x equals... that should be a 4. Silly me. Yeah, I factored out 4, so x equals plus or minus 2. So x is equal to plus or minus 2. However, when we take it back here, we have y squared equals 2 times 2. So y squared equals 4. or y equals plus or minus 2. That's okay. So when x is equal to 2, we get y is plus or minus 2. But when x is equal to negative 2, we get y squared equals 2 times negative 2. Well, we can see that's going to be an imaginary number. We're going to have y squared equals negative 4. And you can tell at this point in time that's going to give you y is plus or minus the square root of a negative number. So we can disregard that. So when x is equal to 2, we get y is plus or minus 2. So we have two values, 2, 2, and 2, negative 2. And then, of course, you have to find the z values that go along with these two. So let me do it this way. Let's get rid of that and that. Say, comma, some z value, comma, some z value. You have to find the z value. I'm too lazy to do that. Okay. Now, we also have y equals 0. We can't forget about that. And over here, we can match it up. We'll see that the x equals 0 and the y equals 0 go together. So we also have the point 0, 0 and some z value. So we're going to have 3 different points. Those are our 3 points. And then when you test them in the Hessian, got to go back and see what our partial derivatives are. So plugging everything into the Hessian, let's do this. I don't want to have to be scrolling back and forth. So what do we need here? We need, I don't need any of this anymore. So H is going to be fxx times fyy minus f of xy squared. So the Hessian is going to be 12x squared times all of that, negative 16x plus 24y squared. And I have to do some more erasing. This is fun erasing. And then minus f of xy minus negative 16y squared, right? All right, so there's my second partial derivative with respect to x. There is that minus that squared. All right, then you just have to plug. So when x and y are 0, what are we going to get? Well, this term is going to become 0, which means this is all going to be 0. Minus 0 is going to be 0. And so we have 0, the point 0, 0, 0. And that gives us a Hessian of 0, which means it's inconclusive. We don't know. Tells us nothing. Then you're going to have to go back and take your other 2 points, which was 2, 2, and 2, negative 2. Take 2, substitute 2 in for the x, 2 in for the negative, and plus or minus 2 in for the y's, and see what you get. And so you will either end up with probably relative maximums or relative minimums, possibly a saddle point. So it's just a matter of substituting the numbers into the x and y values in there, see what you get. All right, have fun with that.